Hello everyone, welcome to my channel. This is a video about understanding Java classes and objects by comparing it to real-world examples. So I hope this will clarify what objects and classes are in Java. So the first thing I would like to point out, when you look at classes, there are two ways of looking at this. The first one is the real world example. The real world, like we human beings are used to classify stuff, categorize them in different things, and we name them, we give them different names. When we don't know something, for example, we call it a thing. And the other part is virtual world. So that's virtual world created by human beings, like internet, network, computers. So like networks in general, like we have computers connected, and then we have devices through internet that they are connected, and we as a human being want to pass our messages and ideas through internet and share it with others. So the thing is, we try to replicate whatever we see or the stuff that we know in the real world and put it into robots or machines and expect them to do certain things in certain ways. For example, we do know how to multiplicate something, then we want the computer to do that for us, because it will do faster and it's a machine, so it doesn't get tired. And the other thing is the establishing or replicating the ideas into the virtual world. Like we have Facebook, we have LinkedIn, and we replicate our identity information. Like we create our own profile, we give it our name, we give it our job description, all these things. So whatever we have in the real world, we are trying to put that in the virtual world and communicate through that. So that sometimes it gets confusing when you're a beginner learning Java. When you look at classes in the real world and once you look at the code, it makes it confusing. So in the real world, we human beings always give name to stuff that we don't know, where we discover. And if we don't know something, we can call it alien, we can call it unknown, we can call it things. The common thing, like, oh, that thing, what thing? But it doesn't matter, just something. So we put it in a class. And for that, we have classified most of the stuff in the planet. So for example, we have a human being class. I mean, you can look at this picture. You have people like in different colors, black, white. Or like if you go to travel around the globe in different countries, you ask people like, who are you? And they would say, I'm a human being. So regardless of color, race, every person is a human being. And since they have the most properties are common, we have classified it or categorized it as a class of human being. So we call it a class of humans. And that includes female, male, and whatever the most identity or people identify themselves with it. But the common things are like all human beings have hands, legs, face, they talk, walk. So these are the properties and attributes that are common. So that's why we have a class of human beings, and we can translate that into a person in computer and create a class and class from that and objects from that class. So if you're looking to your screen, now you can, if you're in a class, look to your right, your friend is sitting there, you're an object and he's or she is an object. Everything is common, but there are differences. Your name is different, that's your property. Your age is different, that's your property, or it may not be different. And you talk different, you speak different language, that's the methods or behaviors. And when you try to talk to each other, and that's your interface. So you establish connection between yourselves. So that's an example for the human beings class and object. So human being the class, and you, your classmates, being the objects created from the human being class. So the other thing, for example, is to clarify it more. We have class of animals. I mean, we have wild animals, domesticated animals, which means we can subclass this one to say like first class animal, subclass domesticated, subclass wild animals. So two different subclasses, then we create an object from each one, a lion, a cat, a dog. So all these things belong to this one. So we have the class, we have the subclass, and then we have the objects. These are the objects that they're all identical except how they look and talk. So most of the stuff are common. So that's what is an object created from a class that they look like that or have most common things shared. And then we have, for example, produce, like fresh vegetable and fresh fruit. The same thing, we can subclass it. We can have it under products like produce, and that fresh produce would be vegetables, and then the subclasses would be like fruits. And then we have a group of objects, like look at these, all these are common things. So all of them have dimension, circle, round, and that's a subclass of fruit, so produce. And then we created objects from it. So we have all these objects that they look, or mostly they have the same property and behavior, but the properties, values, and data are different compared to each other. Or an onion compared to an apple, or an apple compared to a peach, stuff like that. So I hope this gives you an idea. Now we can look at around that we have classified or categorized everything in this planet in different classes. And if we just say like a person, a human being, probably in our mind it crosses like there are 1,000 different people live, 1,000 different people speak different languages, and people have different skin tone, they have different attitudes, properties, and behaviors. So all these things, but still if someone says a human being, we were like, yeah, that has 2 legs, 2 hands, and all these common things. And some may have an accent and not have it, but that's like we go for majority of the shared properties and behaviors. And that's why we talk about objects and then abstraction and other stuff in object-oriented programming. Because the thing is, in object-oriented programming, it's based on objects that is around us, or that's what we try to replicate. When we try to learn Java, we get confused when we try to replicate our ideas into codes, because the real world scenario is different than writing it into a code. Speaking is different than writing. If you just talk to somebody, it's easy to just say what you want. But what if you write a letter? Then you have to look at where your subject is, your object is, how you want to express yourself, you want to transfer your ideas into the paper so you can deliver your message. And that's the same kind of thing when we write code and we try to communicate with machines and robots. And when we try to replicate the real world into code, we get confused, because in real world, for example, we are born, and in Java we instantiate an object from a class. So we design a class, we instantiate an object, and it gives us an object. But that's the similarity, because we do the creation or instantiation of the object from the class, which is different than as naturally born. So when we transfer the idea, that's where we get confused, when we have a conflicting way of doing something that we at the beginning don't understand it. But as long as when you type code and the code doesn't run, then think like what you have done wrong that the computer doesn't understand your instruction. So let's take a closer look at this. For example, we have a human being class, or we can call it a person class, because that's easier to translate it into code. And the person class has a property that's name, gender, age, height, weight, color, race, and it has behavior, which is the method, and that talks, listens, runs, jumps, and does all the other stuff. But the one thing common, if you take these properties in behaviors or methods, apply on each individuals here, it will have different values. This person has a different ethnicity, and this one has a different one. Different names, different size, different height, different weight, and they talk and sit, behave differently. You can look at their faces and you know that each one has reacted differently. So the common things are they're all the same people, they're all human beings, but their identity is different, and that's the property. And the way they talk, behave, that's the behavior, is the method. So that means when you have a database, you have tables of employees, customers, they're all human beings, but each one has different information and different identity. An employee mostly is working to get paid. A customer is mostly buying the stuff and paying you money. So they like the general. A customer can be an employee, but let's put that aside to just make it easy to understand it. So we have all human beings, but different properties. If you add job title here, then it would be a totally different person for the company. She may work for one company and she may work for another company. So these are the things that job title is the same property that she works or he works, but what she does, that's different. That's the behavior. What she does, what's the job, that's different on each individual. So the same thing, just talked about it. That's an example. You have two different person. We have, for example, a class person, and then we create an object. This object would be John, this one would be Miriam, and they will have all different values, and their identity is different than each other. But it's still they're an object created from a person class, or we can call it from this human class. But when we translate the code into the idea into code, there will be a difference. Like it's easier to understand a human being class here, but when you create a class, it's easier to type a person because it's easier to understand that when you have it in writing. And that's a person class, and then from that we instantiate a person object. The name would be John, male, on all these identities. One speaks couple languages, the other one speaks different languages, and then one runs, the other one doesn't run at all. And each object is different, and they all have the same identity or properties. Like they have the same properties and behaviors, but their identities are different. So the last part, when we translate that into code, the human world is that simple, easy. You talk, smile, or anger, show reaction. That's your interface. You show a bad reaction to deny someone, reject. You smile to welcome somebody. That means that when we translate that into an object, so if it is a private data, someone says hello, we check out, do we have a setter and getter to say yes, to say what's, for example, an object comes and says like, hey, I want your name. What's your name? Because I need that to show it to the user. And the object checks, is it private? Yes. Does it have a getter and setter? If yes, it's the interface gives the name. If it doesn't, it denies. Says like, no, we can't see it. And that's the idea of hiding data and putting it into one object. Remember, in Java or in object-oriented programming, the algorithms and data structures are bundled into one object. I mean, it's instantiated from a class, but once you create an instance of an object, then that object holds all those properties, behaviors, or codes that you have written in the class. Now the newly created object holds all those conditions and things that are mentioned. So now this object is pretty much kind of independent person one, Tony, with all these identities. So we use the class to instantiate objects. That doesn't mean we modify the class. We don't modify the class. We create an object, and each object will have different data at different stages of the program, and each one will be different, and they can communicate because the algorithm data is inside the object. So that's why it's inside the class and object. In object-oriented programming, both data structure and algorithms, which is like how something needs to be done, is written inside. For example, it's say like if someone types data, check if the job title equals to manager, add the salary 5%. So all those conditions, when you add data into an object, it checks all those things. The algorithm checks it, or the codes that you have written, and if it's true, it makes the changes. If it is false, it denies it. And the last part, to just take a look again, when we translate the human class into computer code, we will have the subclass, the class person, and then we have subclasses like employee and customer. And in subclasses, we create objects of these people. We have managers, clerk, technician. They all have different roles. So that's in the subclass of employee. And then we have customers. And if you look at it, this one, a person has all this name property. We just looked at it. And that's what customer has. And that's what employee has. The couple difference probably is that this is employee that works for the company, and that's the person that buys stuff from the company. And then they can be the same person, but mostly that's the concept. And then you have customer who has who has membership and loyalty, all these programs. And then you have employees at different position with different titles. So that means that you don't have to do a customer class, write everything like name, job title, all these things, and then do the same thing an employee class, name, and all those properties. I mean these things. You don't have to do this, like call this one customer, then do this again and call this person. What you can easily do this is create the person, then only change the parts that are necessary. So the employee would have job title, working, so like what it does, and then the customer buys where he or she lives. So then you save these objects into one table and this one to another table. So to clarify this one, because we do look at the code, for example, we call person, then we say new person, employee, and we give it that name, that's it. And it gets confused. So for that, I have planned to show you a simple application, very simple, how this works behind the scene. Let me see, where's my Visual Studio Code. So this is a Spring Boot project. It's an easy, like very basic project. Once you learn web development, this is the first thing you will do. And in this we have, for example, a class called post, and then we have entity, which is a table. It has ID, private ID, and it has post name, and then the date when it's created, saved, and then we have setter and getter for this one. So, and then we have another layer, what we want to do, how we can find these from the database, and then we have added conditions, how to save into this object people, and then we have something called controller, how we send data and how we delete and how we send values. For example, new posts, we have a form that we post name just like one object, and it comes all the way to model object. So from the form web page, we send data all the way here, and it instantiates a copy of this one and saves it into table each time someone submits. So let's look at that in the browser. So that's my browser, and I say like I want to add an idea like learning Java, for example. Now in here, so when I submit this one, it submits a form, and that instantiates a class which creates an object. So this one just created an object and it's saved in the database. So let me look at that one. So I would like to show you like what happens behind the scene. That's the database name, so SQL Workbench. And there we go. It says show me everything in this one. So you see, I have the same two data here, which I have it over here. So the process is when I submit something in this form, which is this new post HTML form, like when I say submit this one, it sends it to the server, to the backend, and the backend checks everything, instantiates an object which is in the controller. So this is the code. So it calls the object and instantiates the object, and based on this model, which is the class, it creates a new object and puts it into the database. So this one is updated, this one is updated, this one is not. So that's pretty much how we translate the object and classes from a real world scenario into the codes into a virtual world. I hope this has clarified a little bit of stuff for you. If you still are confused or you want more clarification, please leave a comment or send me an email and I will get back to you guys. Thank you for watching. If you like and share it with your friends. Have a wonderful time.